Hey, the video is going to wrap up in 5 minutes, so I'm going to get right to it. Pause this video as you need in order to ask questions, figure things out with each other, and add all the information there. So you should be looking at the purple notes, and the new idea is that when carbohydrates are put into solution, like an aqueous solution, they form rings. If the ring is a 6-membered ring that includes an oxygen, that is called a pyranose, Pyranose. If the ring is a 5-membered ring that includes an oxygen, it is called a furanose, Furanose. Pyranoses and furanoses. You should pause the video in just a minute and get this information down right here. Okay. So this information is kind of a little reference. It talks about what each carbon determines as it goes from a linear structure to a ring structure. Carbon 1 will determine, the OH on carbon 1 will determine whether it is an alpha or a beta form. Alpha points down, beta points up. Just remember bump, beta up. Carbons 2, 3, and 4 will determine the orientation of the hydroxyl groups, whether or not they are pointed down or up in the ring structure. If they are drawn to the right in the linear structure, they will be pointing down in the cyclic structure. If they are drawn to the left in the linear structure, they will be pointing up in the cyclic structure. And lastly, the hydroxyl on carbon 5, if it is a D form, the CH2OH will be what we call flag up. The CH2OH will be what we call flag down if it is originally an L form. Probably a bunch of nonsense at this point. Let's look at a couple examples. The first one is glucopyranose. So it's a glucose, it's a aldohexose right there, 6 carbons. It is a D-glucose because the hydroxy on the last stereo center farthest away from the most oxidized carbon is pointed to the right. It's important to know that as these carbohydrates become their cyclic forms, that the last terminal CH2OH is not part of the ring. This is going to be what we call the flag up or the flag down. It is also important to note that the chemistry involves carbon at number 5, the oxygen in the hydroxyl group, and then the carbon at number 1. So there is a bond that forms between carbon 5 and then the oxygen and the carbon. So these pyranoses have an ether group in them as well. So let's see here. We basically have to figure out how to go from a linear straight chain form to a cyclic form. And we're going to go one step at a time. So first things first, the carbon-oxygen bond is formed between carbon 1 and the oxygen and carbon 5. And depending on how the double bond opens, and you'll see this in just a few minutes with your model labs, depending on which bond opens up, you will either get a hydroxyl group pointed down. This is what we call alpha right here. Or if the hydroxyl group points up, that is called a beta. So this would be alpha D-glucopyranose because it is pointed down. That the hydroxy on carbon 1 is pointed down. This would be beta D-glucopyranose because the hydroxy on carbon 1 is pointed up. And again, it's hard to see that potentially on paper, but when you get to building the models, you'll see that you basically have 2 different stereoisomers that emerge when you form this chiral carbon. In terms of what is the impact of D versus L, these starts off as D-glucose, and when you build your cyclic models, you will see that the CH2OH points up if you do everything correctly. If it were L, if this hydroxy right here were on the left-hand side right there, then this CH2OH would be pointing down. It would look like it was beneath the ring to us. So, next video.